So these are the notes for lesson 4-6, inverse trigonometric functions, which you've already done with right triangle trig, using sine, cosine, and tangent inverse. But this is the part where you're doing this without a calculator. Just on the same part of the BA where we're graphing without a calculator, we'll have some of these problems. Now, you're going to want your unit circle handy, and on that part of the BA, you'll have generated your unit circle. The first thing that we look at is the function of sine, and here's a graph of sine right here in blue. And sine is or is not a function. It is. I just said it was a function, right? Yeah. It is a function because it would pass the vertical line test. Every x would map to only one y value. But then the question is its inverse a function? And what test do I do to tell if it's inverse? Horizontal line test, which is why you see this red line here. So right now, it's not going to pass the horizontal line test. If I tried to graph its inverse, I'd have a lot of outputs, okay? Or it just wouldn't work. I'd have a lot of outputs for the same input. And so what we need to do in order to actually be able to graph it for sine, cosine, and tangent is limit or restrict the domain.
Can I put this in here?
That's fine.
Okay.
So if we look at just one part of sine, starting from negative pi over 2 to pi over 2, we get an output from negative 1 to positive 1. And you can see that on your unit circle. Down here, this is 0, negative 1. And this is 0. This is 1, 0. And this is 0, 1. So from there to there, we have only one output for every x that's on that. Now, if I try to go past that, then I'm going to start doubling up. I'll have more than one. So I need to make sure that I only restrict the domain of sine. Sine's restricted domain will be from, and including, so I need to use a bracket, negative pi over 2 to pi over 2. And its range at that goes from negative 1 to positive 1. What does this mean for its inverse? How am I going to find the domain and range of the inverse? What's true about the domain and range of inverse functions? Swap them. Just like when you go to solve, you switch x and y. The domain and range, this range becomes the domain of the inverse. And the range of this function becomes the domain, or sorry, the domain of the original function becomes the range of the inverse. So we know there's a mapping because we used it in right triangle trigonometry. Hey, if you knew the angle was 45 degrees, you could use the ratio of square root of 2 over 2 to help you solve any triangle that had a 45-degree angle. And the reverse was true also. If you knew the ratio of the sides was 1/2, then you knew the angle, depending on whether it's sine or cosine. If it's sine and it's 1/2, then you knew the angle was 30 degrees. So in the regular function, you plug in the angle, and it tells you the ratio. On the inverse, you plug in the ratio, and it's supposed to map to only one angle. And that's why it's restricted to this, because if we went to the other side of the circle, we'd get other values that were the same. So when we come down here and you're going to want your unit circle handy, find the exact value of the expression if it exists. So remember, if it exists means it has to fit in this interval. The domain that we're looking at, that's all we can put into the function, and it better map to something between here. Okay? So find the exact value of each expression if it exists. Arc sine, which, by the way, arc sine is another way. Why is it doing this? Arc sine is another way of saying sine inverse. So don't let that notation throw you off. Arc sine of square root of 2 over 2. And this is the non-calculated portion, so we go to our unit circle and we say, well, first off, right, if I'm talking about sine, that's from negative pi over 2 to pi over 2. I'm in which quadrants? quadrant 1 and quadrant 4. Now what I have to really be careful of, it's tempting, and I did this earlier in third hour, that in quadrant 4 you're just like, oh, look, this is 11 pi over 3 or whatever, over 6. What is it, 11 pi over 6 or 5 pi over 3 or 7 pi over 4. But that wouldn't fall within our domain, okay, of our original, wouldn't fall within our range. So when we do this, we have to talk about pi over 6, pi over 4. These are our possible options that are on the unit circle. Pi over 3, negative pi over 6, negative pi over 4, negative pi over 3. So if I list my answer, I don't want to list it as 11 pi over 6, which would be right here. I'd have to list it as negative pi over 6. So as I look at this and say, okay, arc sine, I also want to know, hey, here sine is positive. Remember, all students take calc or a smart trig class. Sine is positive here and sine is negative here. Well, you're telling me that the output or the ratio of sine is positive. So I have to be in quadrant 1. And in quadrant 1, I can see right on my unit circle that that matches up to an angle of pi over 4 radians. If it had been negative square root of 2 over 2, then it would match up to negative pi over 4 radians. Our next one has sine inverse of negative 2 pi. Does that fall between negative pi over 2 and pi over 2? No. So this one does not exist. Now you can say, well, it is coterminal with this and that. And if I'd asked for reference angles, that would be one thing. But if you try to put that in the function, it doesn't recognize it because it's not fitting on its domain. Sine inverse or arc sine of negative 1, that is a ratio, right? Negative 2 pi, by the way, was negative, what is that, negative 6 point something, which is not between, so that's not going to work. All right, so negative 1. So we're looking at a ratio of negative 1 over 1 or just negative 1. Where is sine negative 1? On my unit circle, sine is negative 1 at 3 pi over 2, but I can't put that because it's not in my domain. Negative pi over 2. Yeah, if you look at your unit circle, that's right down here, 0, negative 1, which normally is 3 pi over 2, but we can only do from negative pi over 2 to pi over 2. Any questions on that? All right. Good news is you're not going to have 3 of these, but bad news is cosine is different, of course, than sine. So for cosine, and the reason being, what is the reason? Why can't I just use quadrants 1 and 4 for cosine? Does anybody know? Well, it starts at 1, which that's a good point. It's okay, I'm okay there. But why can't I use quadrant 4? Actually, because cosine is positive in quadrant 4 and in quadrant 1, right? So then I'd have 2 outputs again that are the same. So that would be problematic. So that's why cosine goes from 0 to pi when we're looking at restricting it to find cosine inverse. Goes from 0 to pi because in quadrant 1 cosine is positive and in quadrant 2 cosine is negative. Sine is both positive, yes. Yep, in first and second quadrant sine was both positive, otherwise I would have just done 0 to pi also. So now we have our restricted, just to look at the graph, here's what cosine's been restricted to. Max height 1, min height negative 1. So that's our range for the cosine function. So the range is negative 1 to 1. And the domain for our restricted cosine function is 0 to pi. Well, just like sine, if you're looking at the inverse, the x and y, so the domain and range switch, our new range is 0 to pi when we're talking about arc cosine or cosine inverse. And our new domain is going to be -1 to 1. So if you have cosine inverse or arc cosine of any number between -1 and 1, there will be one output that matches, and that output will be the angle that it matches up to on the unit circle. So as I look to find the exact value, and I got to remember that I'm going from 0 to pi. I don't have to worry about negative angles like I do with sine. Going from 0 to pi, those are going to be my outputs. My inputs are the actual ratios. So I have -1/2. Well, if I'm doing cosine inverse or arc cosine of -1/2, which quadrant am I in? 2. So I go to quadrant 2, and I say cosine is -1/2, 2 pi over 3. And then arc cosine or cosine inverse of square root of 3 over 2.
Since it's 2 pi over 3, don't you have to do like negative pi over 6?
No,
You
I
can.
had to. I can because for cosine, I'm in quadrants 1 and 2, which goes from 0 to pi. In sine, the reason we went backwards from 0 for sine, we had to go up to pi over 2, and that gave us our 1. And then to go, if I kept going, I'd go back to 0. So I can't keep going because I get the same numbers on these sides, the same height. So we ended up doing this way instead, but instead of like skipping half the circle and making our angles positive, it's defined as from 1 to -1, or from pi over 2 to -pi over 2. That half of the circle, just with negative angles. Arc cosine of square root of 3 over 2, it's positive, so we know we're in quadrant 1, which means it's pi over 6. Cosine inverse of -2. Is that on our domain? Nope. Any other questions? By the way, cosine, sorry, what's wrong? Is this, did I write pi over 2? I meant pi over 6, sorry. Did I say pi over 2? I said pi over 6 and wrote the wrong thing. Okay, sorry. Also, think about this. Cosine is adjacent over hypotenuse, especially if you think about it in terms of the right triangle. Can it ever be bigger than 1? No, it always has to be left, right? So, except for when we get to obtuse cases, and then it can be, but it can't be bigger than 1. So there's our answers for cosine. Well, here, this is the good news. Cosine's the one we like because we don't have to think about negative angles. Here's the bad news. Tangent, guess which one tangent's like? Sine. It's like sine. You have to think about from -pi over 2 to pi over 2 for tangent also. So again, when you go to do these problems, you might want to like just mark off pi over 6 because your unit circle won't be in terms of this. And then down here would be -pi over 6, -pi over 4, and -pi over 3. That way you won't write down the wrong answer. All right, so restricted tangent, again, from negative, by the way, that's 1 period of pi right there. When we graphed our parent function, we did that domain, or at least for the first period, from -pi over 2 to pi over 2. So that's our domain. It should be in brackets. Our range is a little bit different than sine and cosine. I should have left myself some more room there. Does our range have a max or min value? No. So basically, if you give me any real number, I should have an answer for tangent. Now, if I'm expecting you to use the unit circle, it'll be ones that I can get using y over x off of the unit circle. But there's other ones, we'll get to that in a second. But basically, our range is any real number. So it's -infinity to +infinity, which means when I go to evaluate the inverse, you can give me any number as a ratio, and there will be one angle that matches up to. So my domain for arc tangent is going to be negative infinity, positive infinity. I can have any input, and my range will fall somewhere between negative pi over 2 and pi over 2. Some of you are going, okay, that's mind-blowing. How can the domain go for that? But it does, because we're talking about fractions and dividing. All right, so find the exact value of each expression if, great. Find the exact value of each expression if it exists. So arctangent of 1. So I'm going to look at this circle right up here. It's positive. Where is tangent positive? In quadrant. Remember, we're only in quadrant either 1 or 4 over here. Tangent is positive in quadrant 1, just like sine, and tangent's negative in quadrant 4, just like sine. So because it's positive, I have to be in quadrant 1. So I'm going to look in quadrant 1. And I'm like, well, the ratio is 1, so it had to be a number divided by itself. Most of you know it's going to be pi over 4. Square root of 2 over 2 divided by, or multiplied by the reciprocal of square root of 2 over 2. So again, this is the ratio. By the way, tangent is y over x. We're given the ratio, we're trying to match up which angle has that ratio. So then we have over here tangent inverse or arctangent of negative square root of 3 over 3, and I have people who tell me every time they take their BA, I have at least one person who says it, that's not on my unit circle. You're right, because your unit circle has sine and cosine on it. So you're looking to see, can you calculate this value? And remember, the domain is negative infinity, positive infinity. Can you calculate this value of tangent using things on the unit circle? Since it's negative, we're going to be in quadrant 4. So I'm going to look down in quadrant 4, and I obviously know it's not 7 pi over 4, which for us we would have listed as negative pi over 4. So I'm going to look at negative pi over 6, and I'm going to look at negative pi over 3. I'm actually going to look at both of them. And I'm going to remember to do y divided by x, or y times the reciprocal of x. That's the same thing. So this will be, I either have at negative pi over 6, it would be negative 1/2 times 2 over square roots of 3, or it might be negative pi over 3, which would be right here, and on our unit circle that would be negative square roots of 3 over 2 times 2 over 1. Which one is it? See if you can figure it out. Hello? I'll let her know. Thank you. Bye. Hello? Okay, sounds good. All right. All right, bye. Somebody's leaving. I think it's Ashley.
Me?
Crap, somebody told me they got another call. One of you's leaving. Text your mom.
I don't think I'm leaving.
Somebody. Haley, you're leaving. It's you. Sorry. All right. Arctangent. Oh, we didn't finish this. Which one is it? Negative pi over 6 or negative pi over 3? Well, look, if I cross these out, I have negative 1 over square roots of 3. And if I rationalize it, I get negative square roots of 3 over 3. So we have a winner right here at negative pi over 6. Good. And then for this next one, positive, it's either the positive of this or the positive of this. Look at what this one multiplies to. Square root of 3 over 2 times 2 over 1 is square root of 3, so it is pi over 3. So I'm doing y's divided by x's and seeing which one will come out to the ratio that's inside the arctangent. I did all that without my mic, sorry. All right, what I'd like you to do is take a moment. This is not too bad, but it looks complicated. Right now I just want you to do this part. See if you can find the correct value for that part, and then we'll talk about what we're supposed to do to it after that. So if you did this correctly, negative 1/2 is going to be in quadrant 2. that is the first point, be 11 pi over 6, but you have to have it as negative pi over 6. However, we're not done with the problem, so we have a little bit more to do. We're going to have to do the sine of that. We'll come back to that in a second. This one, tangent inverse of square root of 3, we just found the positive value of it up here. So it's just opposite of pi over 3. Any questions? It is, oh no, it should be positive. I'm sorry, it should be positive. You're right. All right, so we got those right off the unit circle, remembering that sine goes from negative pi over 2 to pi over 2. But we're not done. I did have somebody in my one class say, well, Mr. Ritter, there's something that you should see about letter A right away. If sine and arc sine, they are inverses. Inverses undo each other like squaring and square root. So I really probably didn't even have to do this to know the answer was going to be negative 1/2. Because if you go to negative pi over 6 on the unit circle, it matches perfectly to negative 1/2. Can you do that with letter B? No, because it's a different trig function. So they're not going to undo each other. Now that we know the angle pi over 3, we can go to pi over 3 and evaluate cosine. Cosine at pi over 3 in quadrant 1 is 1/2. So my final answer for letter B is 1/2. So here's what happened in letter B. First off, it said tangent inverse. So I found out which angle matched up to square root of 3. It was from quadrant 1. It was pi over 3. And now I have that answer. I have to plug it, because right, order of operations, we do what's in parentheses first and then the stuff outside. Now I have to find the cosine of pi over 3. So in my unit circle, I look at the x-coordinate, where it's pi over 3, and the x-coordinate is 1/2. So the next one, cosine of pi over 2, this is the reverse. They're going to tell us that and want us to give the ratio and then do the arc. Yes?
For B, isn't the x-coordinate of pi over 3 square root of 3 over 2?
That's the y-coordinate. Might have a wrong unit circle.
What?
All right, arc sine. Let's look at cosine of pi over 2. Cosine of pi over 2 is 0. That's what cosine of pi over 2 is. But now that we know the ratio, we have to do sine inverse of that. But it has to be, again, from the negative pi over 2 to pi over 2. Well, that's 0 at, 0 radians. The ratio is 0 at 0 radians, yeah.
Can I use lotion, or is that like...
Is it centered? Is it centered?
It's centered.
I have unscented.
Okay, yeah.
Letter D. What's the tangent inverse of negative pi over 4? It is, yeah, or not tangent inverse, sorry, tangent of negative pi over 4. I said that totally wrong. There would be no number. Tangent of negative pi over 4 is negative 1. That's the ratio. And now I'm doing sine inverse, so I should have an angle back as my final answer. And sine inverse of negative 1, negative pi over 2, right off the unit circle. So just, they're going to go back and forth between the two. You just have to remember, if I'm doing sine, I have the angle, I'm finding the ratio. If I'm doing sine inverse, I have the ratio, I'm finding the angle. Now, you saw with tangent that its range, or its domain for tangent, you don't need to write this down, was negative infinity to positive infinity, right? So does that mean that only the values on our unit circle are going to work for this thing? No. So if it's numbers that you recognize and say, oh, that is from the unit circle, I'm going to use my unit circle, great. But if it's not, then we have to go back to something we learned pretty early on in the unit, and most of you were pretty decent at. Come on, whatever. All right, and that is to remember to figure out which quadrant we're in. If we have sine or tangent, we'll be in quadrants 1 or 4. If we're talking about inverses. If we have cosine, we'll be in quadrants 1 or 2. So if we've got sine inverse or tangent inverse, we're in quadrants 1 or 4. Cosine inverse, we're in quadrants 1 or 2. And we want to keep that in mind. Because if they give us some crazy ratio like 3/4, and you're like, there's no way to get 3/4 from the unit circle, then you're going to have to do this. You're going to have to figure out which quadrant you're in. You're going to have to draw your triangle in that quadrant. So I'm drawing 4 different triangles here. You got, or 3, not 4, because I'm not going to be in that other quadrant. You got to figure out which quadrant you're in, given the trig function. And then you just have to remember what the ratios are. Oh, not of x, of theta. By the way, theta would be here, here, or here, depending on which quadrant we're in. How is sine defined? 1 over what? Opposite over hypotenuse, but in this case, y over r, the height over the radius. Cosine is x over r, and tangent is y over x. And then we want to remember that our inverses, or not our inverses, our reciprocal functions, cosecant, oh, that's crappy. Cosecant is r over y. Secant is r over x. That's a popular one among future pharmacists. And cotangent is x over y. So just remembering that, you guys did this before where you drew your triangles and said what the ratios are. Here's the thing, on the other one, you knew the angle. Are you going to, if you have these numbers, are you going to know the angle without your unit circle? No. But that doesn't mean you can't use a picture to help you find the other thing they're asking for. So let's take a look at this one. We have find the exact value, arc sine of 3/4. So they're giving me a ratio, it's sine inverse. It's got to be between negative pi over 2 and pi over 2. So which quadrant am I in if it's positive? I'm going to be in quadrant 1. So I'm going to draw a triangle like it is in quadrant 1. And here's my theta. I have no clue what theta is, but that won't stop me from being able to find all of the 5 other trig functions if they ask for them. So when I look at this problem, they're asking me to find cosine. Well, sine is y over radius, or opposite over hypotenuse if you want. So if I do Pythagorean's theorem, 16 minus 9 is 7. Is that right? So this will be the square root of 7. My math isn't always on, so I should probably have written it out. It's the square root of 7. So now when you ask me to find cosine, I don't really need the angle to know what the cosine is going to be, because I just need the adjacent and the hypotenuse. My final answer is square root of 7 over 4 for this problem. What's up? Are you all done?
Yeah.
Oh, okay. Love the hair, buddy.
Oh, thank you. I feel like a rabbit.
Arc cosine of negative pi over 4, or negative 1/4. What quadrant am I in if it's a negative ratio? For cosine, it's either 1 or 2, so I'm in quadrant 2. So I'm going to draw my triangle in quadrant 2. There's my theta. Cosine is adjacent over hypotenuse. And I can do Pythagorean's theorem again. 16 minus 1 is 15, so this is the square root of 15. And now they want cosecant. Well, I don't think in terms of cosecant, even though I know the ratio is up there. I'm going to find sine, because I know it's the reciprocal. Sine of the angle would be square roots of 15 over 4. So cosecant is going to be 4 square roots of 15 over 15. And if I could reduce it, I would. Please take a minute to try 2 problems. I'm going to ask you to try at least C or D, pick that as 1, and then pick, I'm sorry, D or F, wow, and then 1 from here. I'm going to put all 4 answers up, so whichever one you choose, that's up to you for how you pick it. But I want you to try D and F, one of those, and C and E, one of those. 1 second. In just a second, I'll post the answers. D. So looking at D in particular, so the triangles are drawn. You can see which quadrants they're in. C was in quadrant 1 because it was positive. D was in quadrant 1 because it was positive. Cosine was negative in E, which meant it was in quadrant 2. Had it been sine or tangent, it would actually be in quadrant 4, but I'd use the negative angles instead. And this one's positive also, so it was quadrant 1. For letter D, they say 9/14. Whoa, crazy things. All right, so this is my angle right here. The opposite is 9. The adjacent is 14. I have to find the hypotenuse. 9 squared is 81. 14 squared is 196. Add them together, you get 277. And since you don't have a calculator, hopefully it's not a number you have to break down.
That
but
was really
that's,
easy.
yep, and now I just have to do cotangent. Some people were mad at themselves. They're like, wait a minute, cotangent is just the reciprocal. I could have just flipped it. But that's okay. If you still went through that process, you'd still get the right answer. Any other questions? Oh, I know what I wanted to point out to you guys. So back in Algebra 1, which for some of you was like 7th grade or 8th grade, we had the perfect squares. 1 squared, 2 squared, 3 squared, 4 squared. I'm going to do it like a Dr. Seuss book, just kidding. 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, 11 squared, 12 squared. What is 13 squared?
169.
169, and that means 14 squared.
196.
196, and then 225. You were supposed to memorize up to 15 squared. If you didn't, you were supposed to know that in geometry too, but for most of you, that was 2 years ago also. So if you can't, just do, I know, but we don't get a calculator in this part. That's the part that stinks. So you could do lattice multiplication if you had to. Or just do like regular old 15 times 15, not divided times. 5 times 5 is 25. 15. 0. Yeah, good luck with that, especially with my handwriting. All right. You have a worksheet next week, or next class, we're working on the review guide for the BA.